Welcome to tonight's video on finding trigonometric values at any angle. Unfortunately, as it says here, every triangle is not a right triangle. Thus, the right triangle definition of the 6 trigonometric functions, SOHCAHTOA, is very limited, just to right triangles, and that theta must be an acute angle. Before we get to the new definitions, we're going to explore some concepts and hopefully make sense of connections. So first, let's do that. First, let point P, 3, 4, be a point on the terminal side theta, intersecting a circle with radius r. So first we're going to sketch theta. And 3, 4 is in the first quadrant. Here's 0, 0. And here is 3, 4. And so there's the terminal side of theta. What is the radius? Well, the radius is this right here. If you draw the circle, with the center at 0, 0, the radius you would use to find is the distance. So the radius is equal to the square root of 3 minus 0 squared plus 4 minus 0 squared. So radius is the square root of 3 squared plus 4 squared. So the radius is equal to 5. And if you draw the reference triangle right here, here's your reference triangle. Label theta prime, the reference angle, right here. And the sides of the reference triangle, well, this side here is 3, and this side here is 4. It says find the 6 trigonometric functions of theta. Well, the 6 trigonometric functions of theta using the reference triangle, the sine is 4/5. The cosine is 3/5. The tangent is 4/3. The cosecant is 5/4, the secant is 5/3, and the cotangent is 3/4. Notice for the reference triangle, the values are the same. The reference triangle, the sine is 4/5, cosine is 3/5, tangent is 4/3, cotangent is 3/4, secant 5/3, cosecant of theta is 5/4. So notice in the last one that the reference angle, the values of the reference angle and the angle are the same. Basically, the reference angle and the angle are the same because it's in the first quadrant. So if you do the same thing for number 2 and sketch the point 6, 1, here's 6, 1. It starts at 0, 0. So this is theta. And the reference triangle is the same as theta. Right? So here's 1. Here's 6. Here's 1. So to find r is equal to the square root of 6 minus 0 squared plus 1 minus 0 squared using the distance formula. So the square root of 6 squared plus 1 squared is equal to rad 37. So to find the sine, you go 1 over rad 37, which rationalizes to rad 37 over 7. The cosecant would just be rad 37 over 1, which would be rad 37. The cosine is 6 over rad 37, which is equal to 6 rad 37 over 37. The secant is just rad 37 over 6. The tangent is 1/6, and the cotangent is 6. So now if you look, sorry, gotta do page 2. Page 2 has the same concept. It says let the point P 27 be on the terminal side theta. So 27 would be like up here. And draw the circle centered at 0, 0. So here's the centered 0, 0. And the radius, well, to find the radius, we just go the square root of 2 squared plus 7 squared, because 2 minus 0 is 2, and 7 minus 0 is 7. So the radius is equal to 4 plus 49, which is rad 53. Drawing the reference triangle using the reference angle here, which is the same as theta, right? Because theta, it's in the first quadrant. So you have 7 here and 2 there. So basically the sign is 7 over rad 53, which rationalizes to 7 rad 53 over 53. The cosecant is rad 53 over 7. The cosine is 2 over rad 53, which rationalizes to 2 rad 53 over 53, and it's rad 53 over 2. And then the tangent is 7/2, and the cotangent is 2/7. So the next problem says, let point P be a point, assume first quadrant for now. So x, y here. Intersecting a circle with radius r. So if the radius is r here, and the center is 0, 0. So notice if you draw the right triangle, this will help you get the basic definitions for any angle. Because notice this is always x, and that is y, and this is your reference angle. So the sine is y over r. The cosecant is r over y, because you have opposite over hypotenuse and hypotenuse over opposite. Cosine is x over r. Secant is r over x. Tangent is y over x. Cotangent is x over y. So these are your new ratios for the trigonometric functions of any angle, depending upon what the radius is and what the point is that intersects the circle. So it says here, while the above angles or above problems have a point that is in quadrant 1 and an acute angle that is a right triangle, these examples are easily extended to allow the point to be in any quadrant with an angle theta having any measure. So let's look at the next page. So the general definition, as we talked about, if theta is an angle in standard position where P is the point on the terminal side of theta intersecting a circle with radius r, so then you have your 6 trigonometric functions, just like we found. And it says there's several items you should notice or be aware of. Whenever you're asked to find the 6 trigonometric functions of any angle, you will always present your answers in a format given above. No need to state the restrictions. Notice that the 3 trigonometric functions in the right-hand column are the reciprocal of the 3 in the left. We've talked about that. We've talked about that with right triangles. Finally, notice that if you take the ratio for sine and actually divide it by the ratio of cosine, it will give you tangent. You don't really need to know that right now. That's what's called a quotient identity. Next year in pre-calc, we'll talk about that. and the radius r is associated with a length, therefore it will always be positive. That's a very important point. X and y do not have to be positive because those are points on the coordinate plane, but the radius is always positive. So number 5, let point -2, 5 be a point on the terminal side of theta. So now we're extending it into the second quadrant. So here's theta. Here's our circle. So the radius is here, and so you can draw the reference triangle, -2 and 5. So the reference triangle of 2 and 5. We'll figure in the negative later. The radius, you can take the square root of -2 squared plus 5 squared. So the radius is 4 plus 25, which is rad 29. So for the reference triangle, it would be the sine is 5 over rad 29, which is 5 rad 29 over 29. The cosecant is then just rad 29 over 5. The cosine is 2 over rad 29, and that would be 2 rad 29 over 29. The secant is rad 29 over 2. The tangent is 5/2. Cotangent is 2/5. Now, because it's in the second quadrant, the 2, or the x, is negative, which means when you find the value of the actual trig function, not just the reference triangle, the cosine and the tangent will be negative, the sine will be positive. So it's 5 rad 29 over 29, and rad 29 over 5 for the cosecant, but this will be -2 rad 29 over 29, and this will be negative rad 29 over 2. And the cotangent will be -5/2, and the cotangent -2/5. So that's the only difference, is the positive and negative. So notice, is theta an acute triangle, an acute angle in a right triangle? The answer is no. Theta here would be an obtuse angle, and the reference triangle is a right triangle, but theta is not. Why does right triangle definition not work for finding the 6 trigonometrics of theta? Because theta is an obtuse angle. And remember, in a right triangle, you only have acute angles. In the first 4 problems, theta, the reference angle, is equal to the angle. Is that true for problem 5? The answer is no. In problem 5, how are the 6 trigonometric theta related, similar, or different to the 6 trigonometric functions of theta? Well, the 6 trigonometric functions of the reference angle, the 6 trigonometric functions of the reference angle are the same fractions as theta. The only difference is whether they are positive or negative. So that's the only difference. So if you look at number 6, it says the point is 2, -5. So now it's here. Actually, sorry, 2, -5 is in the 4th quadrant. It's here. So theta is all the way around there, but this is your reference angle here with your reference triangle and your circle. So your circle would be here. So there's your R. Your X is, or so your Y is 5. Your X is, or sorry, your Y is -5. Your X is 2. So the sine of theta is going to be the Y over R, so -5 over R, and remember R is equal to the square root of 2 squared plus -5 squared. So R is equal to rad 29. So it's equal to -5 over rad 29, which is -5 rad 29 over 29. Cosecant is rad 29 over -5. Cosine is 2 over rad 29, which is 2 rad 29 over 29. Secant is rad 29 over 2. Tangent is -5 halves. Cotangent is 2 over -5. Number 7. Now, with these, you don't even have to draw the pictures. So the first thing you want to do first thing you want to do is find R. So you just go square root of -3 squared plus -1 squared. So 9 plus 1 is rad 10. So then remember, this is your X and this is your Y. So sine is Y over R. So -1 over rad 10, which is negative rad 10 over 10. Cosecant would just be the reciprocal. So it's rad 10 over -1, which is just negative rad 10. Cosine is X over R. So it's -3 over rad 10. -3 rad 10 over 10. Secant is just the reciprocal, so it's rad 10 over -3. Tangent is Y over X, so -1 over -3, which is 1/3. Cotangent is X over Y, so -3 over -1, which is +3. Next one. -4, 0. So if you're looking for the R, it's the square root of -4 squared plus 0 squared. So it's the square root of 16, which is 4. Not the square root of 4, but 4. So sine is Y over R, so 0 over 4 is 0. Secant is 4 over 0, and anytime you have 0 in the denominator, that is undefined. Cosine of theta. Cosine is X over R, so -4 over 4 is -1. Tangent is Y over X, so 0 over -4, which is 0. The secant is 4 over -4, which is -1 still. Cotangent is -4 over 0, which is undefined. Zero, 3, well, the square root of 0 squared plus 3 squared is the square root of 9, which is 3. So the sine is 3 over 3, which is 1. The cosecant is just the reciprocal. It's still 3 over 3, which is 1. Cosine is 0 over 3, X over R, which is 0. Secant is 3 over 0, which is undefined. Tangent is Y over X, so 3 over 0, which is also undefined. Cotangent is the reciprocal, 0 over 3, which is 0. Number 10, If you look, find the radius, it's -5/13 squared plus -12/13 squared. And that's equal to 25/169 plus 144/169, which is 169/169, which is the square root of 1, which is 1. So r is 1, which means when you go y over r, it's just going to be -12/13. And the reciprocal of that is -13/12. Cosine is going to be x over r, which is -5/13 over 1, which is -5/13. And the reciprocal of that is -13/5. Tangent is y over x. Well, here, when you divide two fractions, you multiply by the reciprocal. So notice you get -12 over -5, which is 12/5. And the reciprocal of that is 5/12. For number 11, when you do the same thing, you get the radius is 1. And so the sign will be 4/5. The reciprocal of 4/5 is 5/4. The cosine is -3/5 because it's x over r. And the reciprocal is -5/3. Tangent, when you go -3/4 or -3/5 divided by 4/5, you get -3/5 times 5/4. So you get -3/4, and the reciprocal is -4/3. And when you do number 12 and find r is 1. So it's going to be the sign is y over r, which is just -1/2. The reciprocal is -2. The cosine is x over r, which is rad3 over 2. The reciprocal is 2 over rad3, which is 2 rad3 over 3. The tangent, -1/2 divided by rad3 over 2 equals -1/2 times 2 over rad3. So it's -1 over rad3, which is equal to -rad3 over 3. The reciprocal of this is just -rad3. What is special about problems 10 through 12 compared to 1 through 9? We'll look at the radius in 10 through 12, and you notice in 10 through 12, r is equal to 1. So this is going to lead us to the special case of the general definition, which is our unit circle definition. A circle whose center is at the origin, whose radius is 1, and whose equation is r equals, or in this case, whose equation is x squared plus y squared equals 1. That is our unit circle. And then next video, we'll talk about how to find sine, cosine, tangent based on the unit circle definition.